Hello and welcome to another video of me working through a concept, calculation, or problem to gain a better understanding of the topic. In this video, I will continue to explore Euler's formula with a more complex calculation or application. But before I begin, I like to review and ask myself 3 self-assessment questions, such as what did I learn or relearn, what did I figure out, and what did I realize. Actually, the order is what I like to prefer the order to be in what did I learn or relearn, what did I realize or thought about something as being one way, or it could be another way, or maybe it was a wrong way. And then what did I figure out, as in, was there a solution to something I did? Did I solve a problem? Okay, so let's start with the review. In the previous video, I found the process that changed or converted this expression to this expression. So I have e raised to a power, and the power is inside the parentheses a plus bi, and outside the parentheses multiplied by x. So then I distributed the x to each of the terms inside this parentheses, or to each of the terms of the binomial. So I then gained e to ax plus ibx. Now, I remembered that e to a power plus another number, well, e to an exponent that is a number added to another number, can be rewritten as e to the power of one of the terms multiplied by e to the power of the other term. So e to the x plus b equals e to the x multiplied by e to the b. So I remembered this rule of exponents, then I applied it to this expression. So I had a result of e to inside parentheses e to the power of ax plus ibx. Once I distributed the x to each of the terms, this was the result. And using this concept or rule of exponents, I then got a result of e to the ax multiplied by e to the ibx. Then I noticed that this expression or value is now this expression here. So that means that this expression is the rest of this expression. But I realized that I forgot to put the closing parentheses on that. So now I need to know, how do I get this to be this value? So now I went back to my understanding of Euler's formula, where e to an ix equals, inside parentheses, cos x plus I sine x. So this means that e to ix gives me cos, and the value that is being multiplied by I goes inside the cos parentheses and also the sine parentheses, and the I stays on the outside of the sine value. So now, using this principle of Euler, I applied it to the one that I have here, which is e to the I bx, not e to the ix. This one has a b. So this part, this value multiplied by the I goes inside the cos parentheses and the sine parentheses, and the I stays on the outside of the sine. So now this expression matches up with this expression up here. So now I found the process that took this expression and converted it to this expression. So that's the review of what I worked through. I found a process that converted this expression to that expression using Euler's formula. Now, what did I learn or relearn? I think I relearned the exponential rules of exponents when I have numbers being added as an exponent, numbers that are exponents, or values that are exponents being added to give me a multiplication of the base that remains the same, and the terms being the exponents for each base. So that's what I relearned. What did I realize? I realized either I realized something is another way, or could be another way, or I found a mistake. So I realized I made a mistake by not putting the ending or the closing parentheses in the outermost parentheses. And what did I figure out? Well, I solved or found a solution to a problem by finding the process that took this expression to that expression. So that's what I figured out. So now I can move ahead with a more complex application of Euler's formula. I'm going to erase this part. And write the more complex application. Okay, so now I have two values that have a binomial exponent. One has each one of these values have constants. So this is constant 1. Multiplied by e, which is raised to a plus bi multiplied by x, which is very similar to this, plus c, a constant, which is different, this is constant 2, subscript 2, which distinguishes this constant from this one. So this one is different from that one. And it's also being multiplied by e to a minus bi multiplied by x. Okay, so now this one, the first one problem I worked through had a plus sign, or added two terms. This one is the same, but this one has a subtraction symbol in the exponent. And then this equals, I'm going to write it below this, e to ax multiplied by a cos bx plus I b sine bx. Now I'll close the outermost parentheses, and I was given that a equals, yes, you can see it up here, a equals C1 constant one up C1 plus C2 and B equals C1 minus C2. So that's what I was given. Now I want to figure out how does this expression give me this expression similar to this one, but it seems to be a little more complex. Alright, so I'm going to start by taking one of these terms and finding the expression that in the same way that I did in the previous video, that gives me trigonometric values, as in Euler's formula. And then I'll do the same process with this one. The only difference is this one has a minus sign. Okay. I'm going to write a little bit smaller since I have already used up half of the board, so I'm going to write a little bit smaller. So I'm going to start with this value here. Okay, so I have C1 multiplied by E. Actually, yes, okay. So I'm going to distribute the x to each of these terms in this binomial. So ax plus bx. So x multiplied by a gives me ax, and x multiplied by bi gives me ibx. I like to put the I before the following variables because this bx matches up with this expression inside the trigonometric parentheses, bx. It keeps it organized for me. Okay, so now I have this. Then I'm going to convert it to, using the rules of exponents, with an exponent that has addition or subtraction, and it's now going to become C1 multiplied by e to ax times e to ibx. Okay. So now I'm seeing that I found something that looks familiar. E to the ax is here, e to the ax. Okay. Then I'm going to convert this e to the ibx into trigonometric values. So I'm going to write C1 to the E AX, then open the parentheses, because I'm now changing this value to the trigonometric values, to cos BX plus I sine BX, and close the outermost parentheses. So now I've converted this value into this expression. So that's what I need to do for the second term. I need to go through the same process. Okay, so now I have C2 times E, C2 times E raised to a power that's A minus BI close parentheses X. But I'm just gonna, since I'm running out of room, I'm just gonna go ahead from up here and distribute the X to each of these terms in this exponent. So now X times A is AX, and minus AX minus X times BI, I'll write it as IBX. So now I'm at this stage in the process. So now, using the rules of exponents, I get C2 multiplied by E AX times E2 IBX. So now I'm here at this step in the process. So now I'm going to convert this IBX. Which now becomes C2 E to AX multiplied by cos so I remember I being multiplied by BX. So the BX goes inside this trigonometric function or operator. So it becomes BX cos BX plus, oh, I forgot. I needed to put the minus sign here, minus, because this one has a minus sign, it's not positive. So it's plus sine I sine. The I comes out, I sine minus BX. Then I close the parentheses. Now I remember in my trigonometry understanding that when I have a sign with a negative value inside the parentheses, I can actually take the negative sign out and put it outside of the sign. And that's what we call an odd number. The sign value is an odd number where I can take the negative sign and bring it out. The cosine is different. If I have a positive sign, I can make it a negative sign inside the cos operator or function. So I'm going to go ahead and take this negative sign out and put it in place of this positive sign, making this negative. The reason I'm doing that is because I saw that there's a negative sign in one of these, in this expression here. And the way I can bring a negative sign into this expression is by bringing it outside of the sign expression. Otherwise, I would not have a negative symbol outside to work with. But I remember from my trigonometry classes that I can bring that negative sign outside. So now I have this expression. Okay, so now I have these two expressions that I need to convert to this here, this value. There. But to make room, I'm going to erase these parts that I don't need right now, the previous steps. I don't need these previous steps now. So I'm going to be erasing as I go, just to have more room. So now, from what I'm seeing, I'm very close to getting to this final expression. Now I have, so what I can do is multiply these values through. So I can multiply this constant 1 EAX to each of these terms inside the parentheses. I can do the same with this constant 2 with the trigonometric functions inside the parentheses. So I'm going to go ahead and multiply through. So C1 e to the AX multiplied by cos BX gives me C1 e to the AX cos BX plus C1 e to the AX I sine BX. I normally would bring the I all the way to the other side on the left side, but because I noticed that they want just C1 and C2, I'm just going to keep it this way for now. It seems like it's going to match up better that way. And then I'm going to go to the next expression and multiply the C2 or constant, the second constant, multiply with its exponent. I'm going to take this value and multiply it to each of these terms here. So now I get C2 e to the AX multiplied by cos BX and now I get a minus sign. So I'm noticing that I'm coming very close to the expressions that I'm supposed to find. Equals C2 e to the AX I sine BX. Okay, so now I notice that A is C1 and C2, pause, okay, and then B is C1 and C2, cos, A cos BX and I sine BX. Okay. Okay. All right. So now to make room, I'm gonna erase these calculations or expressions. Here, this one, and this one. Okay. So now I can separate out these terms. Let me just bring this expression up so I can work below. So I'm going to rewrite it. C2 e to the AX cos BX minus C2 e to the AX I sine BX. All right. So now I have this. Okay, so I converted this to this, which is almost the same number of steps when I converted this to that. But now I have another expression that I also use almost the same number of steps to get to these values here. So I have this expression. So what I can do now is combine like terms, in a sense that I write the cos values together and the sine values together, like that. So I'll have C1 times e to the ax cos bx plus see these two expressions gave me these two expressions. They were being added, so I add, so there's an addition here with these two expressions, plus C2, this one is C2 times e to the ax cos bx. Before I bring this expression down also, let's see how I can isolate or take out the C1 and C2 so I can get something like this to be A. Now, what the like term is here is cos bx. So that tells me I can have cos bx times, inside parentheses, C1 plus C2. And now, as you can see, C1 plus C2 is A. So this is now A. So I have A cos bx. A cos bx. That's this. Oh, and I also have I forgot to write e to the ax. That should also be here. But since this is also going to be written twice, I can actually bring this out. E. So I was supposed to write e up here. This caret symbol means I placed the writing or the value up here. So I have e to the ax, and then up here too, e to the ax. I forgot to write that in. So I can also bring the e to the ax out. So I get e to the ax. So I can write it out here, e to the ax. So this is very close to this. I noticed it when I saw this e to the ax multiplied by here, so I was making a mistake by not writing the e to the ax. So I caught that early. So now now this is what I have. That's very close to this part here. Now I'm going to do the same calculation, but I need room, so I'm going to start erasing. I'm going to go ahead and erase this part. Actually, all I need to do is just change the trigonometric values. So all I need to do is erase the cos and write sine, because it's going to be the same thing. The only thing is, instead of cos, I have sine. See that here? But remember, I have a negative symbol out here, so when I write this part, I need to put a negative sign. Okay, so I'm going to start with the top, and the top is just C1 e to the ax I sine bx. So I'll write I sine I sine bx times negative, this is negative here, negative c2 e to the ax I sine again I sine bx, and that would give me, I can take the, so what I have the same is I sine bx in both terms. Okay, so I'll have I sine bx here, and because this is c1 minus c2 e to the ax, I have to change the sign here. So now I have something similar to this, and that becomes b. So now I have b I sine bx times e to the ax, because this is b, this value now becomes b, times I sine bx, and I also will be taking out the e to the ax from here and putting it out here. So that becomes e to the ax. So now I have two, so this is going to be, since the subtraction is b, it's hidden inside this variable. So what I have to write is plus on the outside, because the subtraction is hidden inside the b. So now I have my final, well, not the final, I have the almost last step. So now I have a cos bx e to the ax plus b I sine bx e to the ax. So what I can, so let me rewrite it so it looks, I'm going to erase this and rewrite that so it looks easier to understand. It makes it easier to understand. Okay. Maybe I should turn the other light on, the sun's going down. Okay. Oh, but there's glare on the screen, but okay. So I'm going to rewrite this. Now I have a cos bx multiplied by e ax plus b I sine bx multiplied by e ax. So I wrote this out up here. Okay, so now I notice that this value is also here. So I can actually take this EAX out. So what I can do is now write e to the AX multiplied by a cos bx plus, let me just write this better, plus, I can now bring the I to the left side of the b, sine bx, and close the parentheses. And now I've gotten this expression. So I worked my way through the process from the previous Euler formula video. I applied it to a more complex expression. This was simpler, but then I added two, well, the textbook I'm using for review gave me two of these expressions, slightly varied, and gave me this outcome. And I went through the process to find out how did I get from here to here? And I went through the steps and I found the result which matches up. So B is C1 minus C2 and A is C1 plus C2. It all works out. So I can do a conclusion which is similar to the review and 3 self-assessment questions. So the review is pretty much using the Euler's formula in a more complex expression that gives me a final result. And it is correct. I found the result. And what did I learn or relearn? I learned that the process works in a more complex manner. And what did I realize? Was there something that I thought was one way, but it was another way, or could be another way? Or was there a mistake? Yes, I did make a mistake. When I was writing my exponents, well, when I was rewriting my expressions, I forgot to put my exponent in there. So I use a caret symbol to squeeze it in between my other symbols and letters in the expression. So that's what I realized. I fixed the problem. I did not find something that I thought was one way and that can be another way. What did I figure out? I figured out the solution. I figured out the solution that I needed. I went through my concept, my initial understanding of Euler's formula and applied it to a more complex situation. So I found the solution to that. So I hope this video was helpful, and what I'm trying to do is try to show you how Euler's formula works and with a more complex expression. And in me showing you this operation or process or calculation, it helps me to better understand and to better have a better memory of it. By me writing it out, it helps me to develop my neurons and synapses, make those connections, make them stronger so I can remember it better and understand it better, have a longer memory. And this helps you to understand how some calculations are performed and some principles are used in math, like Euler's formula. Also DeMoivre, I don't know if that's the way you say, his principle is also involved in this, but I just did not show you directly. But I hope that this video was helpful. I'll see you on another one.